Hello and welcome. My name is Cade Van Yaw. This is my Module 6 assignment for Petroleum Computational Methods. And what I'm going to do is basically explain how to solve self-test problem 6 on page 183 of the textbook. So when you open up your book and you see this tank, and what the problem asks is how many barrels will the cylindrical tank above hold? And so there's basically, you're gonna have to do this in say three steps. And this first step is we're going to solve how many cubic feet are in this section here, the cylinder part. So the volume of a cylinder is pi r squared, which stands for radius, and the height. So we have this number here, 14. That is actually the diameter. I know in our little drawing it looks like it could be the height, but it is a cylinder, so the 14 is going to be the diameter, and the radius is going to be half of that. So we know that 7 is going to be our radius. And then we're going to use 28 feet as our height. And of course, pi. So pi, 3.1416. If you're using a calculator and you hit the pi button, it fills the screen up with numbers. The most important thing to remember is the more decimal places you have, the more accurate your number is going to be. And of course, 7 squared times 28. And when you enter that into the calculator, it gives you 4,310.2651 cubic feet. And like I said before, you can keep going with the decimal places. It's really up to you on how accurate you want to be. So now that we have the cylinder, we need to figure out these two little end caps. So they're basically hemispheres, and when you add them together or put them together, they make a sphere. So we need to figure the volume of the sphere, which is 4/3 pi radius cubed. And since they are hemispheres, 7 foot will be our radius. So again, the easiest way to do this on a calculator is take 7 cubed, multiply it by pi, and then multiply it by 4. And then you can divide that by 3. And what that will give you is 1,436.7550. Again, decimal places as long as your calculator will give it to you. And that is the volume of the sphere. So we have to take these two numbers that we have, and we have to add them together. So we take the volume of the cylinder and add it to the volume of the sphere, and that will give us 5,747.0201 cubic feet. But if we go back to our problem in the book, it asks for barrels. So what are we going to have to do? Well, we're simply going to have to take and convert our cubic feet into barrels. So in our book on page 160, if you look around there, it'll let you know 1 barrel is 5.61 cubic feet. There are other ways to come up with this, but we will use this conversion from the book. And what you're going to have to do is take the number you just figured out, the 5,747 and some change, and divide that by 5.61. Because what we're trying to figure out is how many of these 5.61 cubic feet sections can we fit inside this tank. If you multiply it, you're going to get the wrong number. So we enter that into our calculator, and what do we come up with? 1,024.43 barrels. Now, we can check our work behind the back of the book, and it gives us this number. Personally, I would round it down to 24 as a whole number, because when you're dealing with tanks like this, you very seldom have to know the points or less than a barrel. You're usually going for whole numbers. And keep in mind, if somebody sends you this tank, they're probably going to tell you it's a 1,000 barrel tank. Of course, you will need this number if you want to put a sensor in or figure out barrels per inch. But for all practicality, in the field, this would be considered a 1,000-barrel tank. So I hope you learned something. Hope I was helpful, and have a good day.